I'm going to do my best to talk you through a little bit of this lesson on phase shifts. So, as this says, and as seen in the last lesson, the graph of y equals 3x is shown below. So I'm going to go ahead and adjust my graph here. So I've started with a basic graph with all of my shifts at the default values. So the A being 1, the B being 1, no horizontal shift, and no vertical shift. So I'm going to go ahead and just change this to cosine, and it's going to be 3 cosine x. And then I'll go ahead and hide this for a second. So I've got my original graph here, 3 cosine of x. So it says, using this graph as a guide, sketch the graph of y equals 3 cosine x minus pi over 2. So as you start to put in values for x, you're going to notice that every time you put in a value, you have to subtract pi over 2. So if you put in something like, let's say pi, which is 180 degrees, you're going to subtract pi over 2, which is 90 degrees, and then you're actually going to get the output value for 90 degrees. So if if you look at the actual key here, everything is going to be shifted over 90 degrees, because when you go to put in the value for pi, which usually comes up here, it's going to take 90 degrees longer for that to show up. When you put in pi over 2 here, it's going to take 90 degrees longer for that to show up, because the values keep getting subtracted. So you can show that here on our shifted graph. I can make this cosine, and then this is the value that we're adjusting here. So if I want to make that pi over 2, you should get a shifted graph. Now I just have to make sure my A is 3, and you're going to get the same thing that we have here on the right. And if you look at the shifted graph, you can see. So when you put values in here for C, those are what we call phase shifts. It shifts the phase of your sinusoid, which is just a fancy word for a sine or a cosine graph, sine wave. So you can see that that is shifted by that amount. Now if I go here and I just change my x-axis to skip by pi over 2 like it does in the graph on the right, you can see that the points actually match up. So pi over 2 here and 3 versus 0, 3 on the original graph. So it's shifted over pi over 2. So the way that you can kind of think about it is that it takes 90 degrees longer to reach the point that it would have on the original graph. So those phase shifts, when you're looking at a function like here in exercise 2, A, B, or C, as long as your adjustment to the period is factored out, you can just look at the graph and see what the phase shift is going to be. So in this case, it's going to be to the right, pi. In this case, it's going to be to the left, 4. And in the next case, it's going to be to the right, pi over 3. Just like any other transformation that we have, the sign here, don't get tricked and think that that is pi units to the left because it's negative. It actually takes longer to reach the point, so the graph is being pushed to the right. It's being shifted to the right in this case, and then to the left in this case, and to the right in this case. Now, when you have examples like we do down here, where the adjustment to the period is not factored out yet, so in this case, sine of 2 pi minus 8, you have to factor out this 2. So if you come over to my screen on Desmos so I can type and show you, if I start with y equals 2x minus 8, let me just cover up some of my other graphs for now. This is what it's going to look like. If I factor out the 2, I have 2 and then x minus 4. So all I did is just divide both of those by 2. So you'll see that on the graph, they are the same thing. So now I can actually see my shift. So if you don't factor out this value, then your shift is not going to take into account the effect that your adjustment to the period and the frequency has on this function, which was covered in that lesson. So just make sure that you can see what that is and that it's factored out before you try and read the horizontal, or what we call the phase shift, from the equation. So in this case, your shift is going to be to the right 4. If I look at my next example, y equals cosine of 4x minus 2 pi, I have to factor out the 4. So I have x minus, now I'm going to write 2 pi over 4 for a second, and then I'll simplify it. Just remember that when you factor out from something, you are dividing both values by what you're factoring out. So this x, which was 4x, once we divide it by 4, the 4 over 4 cancels, and then also reduce the next part of your function here. So that would be the same thing as writing y equals cosine 4 times x minus pi over 2, because 2 pi over 4 reduces to pi over 2. If I look at my key here, you can see the work done out right there. So the shortcut, rather than necessarily writing the whole function out each time like I did over here on Desmos, you can take your value here for c, and you could just divide it by your adjustment to the period. So that will be kind of a shortcut to get you to the horizontal shift or the phase shift. So you can see in the examples over here, we've done the same thing. So when you factor out pi over 3, it might be easier to think of it as 2 pi divided by pi over 3. So rather than dividing by a fraction, we multiply by the reciprocal, the pi's cancel, and you have 2 times 3 is 6. The same thing with the example here. You take pi over 12 divided by 1/2, which is the same thing as multiplying by 2 over 1, and you get your shift there to the left. So moving on, we have this, here I'll just go to the blank copy, we have this terminology that we want to be comfortable with: amplitude, midline, period, frequency, phase shift. Let's just talk through those really quickly in this example. So I got a whole bunch of stuff here on Desmos. I'm going to get rid of my recent examples, but I do have my equation here with everything filled in, and I recommend that you just take a second and go on Desmos and get this kind of filled in for yourself so that you can look at the same thing. Sometimes if you delete these and put them back in, it gives you a hard time, so you may just have to reset that. There we go. Now my C, for when I look at this equation over here, I've got 5 sine, so my A is 5, so I can make that a 5. I should make sure my graph is gonna sometimes, it's invisible. So my A is equal to 5, my B is equal to 2 in this case, so I'll just drag my B up to 2. Now your C is, remember, the equation up here is in this factored form. So if I write out the actual equation as it's written in the example, y equals 5 sine 2x minus 3 pi, close parentheses, plus 7. That is, I'm going to hide this for a second, that is the same thing as saying y equals 5 sine 2 times x minus 3 pi divided by 2, because I factored out my 2, plus 7. So if you want to use your example here to fill everything in, that C needs to be 3 pi over 2, and my vertical shift needs to be 7. And now you'll notice the graphs are right on top of each other. You actually can't even see the graphs, so it doesn't matter which one you have activated. So in terms of listing out our examples, our amplitude in this case is 5. The midline you can see is this value right in the middle, so I go up to 12 down to 2. The very middle of that is 7, and if you want to see the midline, you can just put in a y equals 7, maybe even make it a dotted line, and you can see that. Now when you go from this midline of 7 up to your maximum of 12, that is your amplitude, and then same thing down to your minimum of 2, that is your amplitude. So in this case our amplitude is 5. Your frequency, now remember the frequency is the number of times the graph will repeat in 2 pi radians. So that frequency, when you're going to calculate it, you can take your period and basically reverse it. So in this case we know our period is going to be 2 pi divided by 2, which is just pi. and so I can show you the work for that. And your period is pi. Now your frequency literally is that value. So that 2 that we have in front, that b, that coefficient, that tells you that the graph is completing 2 cycles from 0 to 2 pi. So 2 cycles per every 2 pi, which you can tell starting here at 0 and finishing up here at 2 pi. If you look at this graph, you have your first cycle, which ends here at pi, and then you have your second cycle. So your frequency is just the number of cycles that occur in that time period of 0 to pi. So moving on to we said our phase shift was, we haven't done that yet, so that is to the right, 3 pi over 2. So the graph has shifted 3 pi over 2 to the right because it's positive. So you can tell, you might be saying, well, sine starts at 0, why is it doesn't look shifted? Remember that positive sine starts by going up and then down and then up and then down. So because this was shifted 270 degrees, it's like sine starting 270 degrees late. Or you could look at the next cycle and think of it starting as 270 degrees early. So this, if I had gotten rid of this shift, if I take this c value and I just make it 0, and I hide the actual, hide my graph here, I got too many graphs activated. So if I make my c 0, for this one, I gotta get rid of my purple one. Okay, so this would be without a phase shift, 0, starting at 0, going up. Now if you notice back here, see at negative pi over 2 where it starts by going down, and then again at 3 pi over 2 over here where it starts to go down, that is what you're going to see happen at 0 when I take this c and make it 3 pi over 2. So it starts to go down. So it's just taking that point and shifting it, and that's where the graph begins. All right, so for exercise 5, it says a graph shown below is a transformation of sine x. Determine the period, frequency, amplitude, midline, and phase shift for this graph. So I'll reset all my values here. I should just be able to cross everything out and make some new sliders. And my goal is to try and recreate this graph here on it's here on the page. So I have these points. You could put them in if you want to make sure. So that's a pretty easy thing to do. You can just put in the point 313, 620, 9, 27, 12, 20, and 15, 13. And you can just have these down bottom so you don't have to worry about them all that much. Now you're going to have to change your x-axis. Obviously starts at 0 and goes up at least past 13, so I'm just going to make it go like negative 5 to 25, and I should definitely be able to see everything. My y-axis, again, let's start somewhere negative. I'm just going to leave that, and then the maximum is 27 on this graph, so I'm just going to go up to like 35, so I've got plenty of room. So you should be able to see the points here that match up with your ones over here. So the first thing is I usually go for the midline first. So the midline is going to be up here at 20. So, and I can even graph that, y equals 20. I know that just because it's the middle of the minimum and the maximum. So that's an easy way to find it, is just take your maximum point of 27, your minimum point of 13, add them up and divide by 2. That's 40 divided by 2 is 20. So you know your midline's 20. So that means my vertical shift here is going to have to be 20. Now I have to change my amplitude as well, so I need this maximum to be up at the maximum of 27. So since my midline is 20 and my maximum is 27, that distance is 7. So I'm going to have to take this amplitude and make it 7. Now you'll notice that my maximum is up near that point, but the rest of my graph is really not shifted well. So another way to continue to adjust this, I'm just going to take this horizontal shift and make it 0 for now. My frequency here is set to 1, so it may be easier for you to think about this by saying, well, I know, here I'm just going to make a new box and shift it up. So I know that my period is usually 2 pi, and the period in this graph looks like if you take a point down here at 3 and then you follow it until it's back down there again, that distance is 12. So that tells you that your period is 12. So one way for you to calculate that, remember there's the formula, your period is equal to 2 pi over b. So let's just fill in what we know, which is we know our period is 12. So if I rearrange, cross multiply, if you just make this 12 over 1, you end up with 12 times b equals 2 pi. So if I show my work here, 12b is equal to 2 pi. And then I divide by 12, so b is equal to 2 pi over 12, which is just pi over 6. So if I go up to b and make that pi over 6, it looks like I'm set up now for the correct period. Now, it looks like this graph is just flip-flopped a little bit, and it might be a little bit off. Can't really tell at the moment. So I think I'm just going to throw a negative in front, and for your amplitude, you should be able to put a negative and it'll flip that graph upside down. And that's going to get you what you want. So if you don't have a graphing utility here to check your work as you go, it's a good place to start. But going forward, eventually you can do this even without having the graph to double check yourself. Finding the midline, doing the period, and checking for all of those, you can get most of your stuff figured out. Now, knowing that your 0 was here and that it was going down first, you either would need to make your amplitude negative, or you need a horizontal shift. So if I make the amplitude positive and I just take this and shift it by 90 degrees, I should be able, or in this case, I have to make my shift based on the number 3. It's not a degrees. So if I make this a -3, actually it's got to be up to, let me put that back to 0 for a second, because this is I want to shift this value back to the beginning. This is where I would want it to start. It's not just shifting the 3 over, because then it's not going to start where you want it to. I'm going to have to shift it so that it's 12 units over. So a shift 12 to the right should be a shift of -12. Now, if you do that, you can see we're going up instead of down. So you should be able to adjust it by half and fix that problem. So again, the reason I know it's 6 and not 12 is because 6 was, I wanted it to go up starting at 6. If I had put in 12, it's going to go down starting at 12. So that's where that little mistake was. So again, if you're here at c equals 0, that's the reason that we're going to shift it over just the 6. So that's the last example, and hope this helps just a little bit. Have fun.